Techniques for surveying. Surveying a rectangular plot. We begin with surveying a rectangular plot of land, after which we will explore surveying non-rectangular plots. Here, one corner of the land has been marked. From that point, the plot extends 300 meters to the north and 700 meters to the east. The known point is marked. From here, the land must be surveyed using the information given. To survey the plot of land given the information that has been shared, one technique for surveying would require the following materials: 100-meter measuring tape, prismatic compass, ranging poles, and 2 people. To determine the boundaries of the plot of land, 1. Mark the node point with a ranging pole. This is the origin of the subsequent measurements. 2. Use the prismatic compass to determine which direction is north. 3. Person 1 holds the end of the measuring tape at the exact point where the first ranging pole has been driven into the ground. 4. Person 2 walks north using the prismatic compass to ensure that they are walking in the correct direction. 5. Once person 2 fully extends the measuring tape, they have walked 100 meters. A second ranging pole is driven into the ground to mark 100 meters. 6. Person 1 walks to the location of the second ranging pole while person 2 rewinds the measuring tape into the spool. 7. The process is repeated with person 1 again holding the end of the measuring tape at the exact point where the second ranging pole has been driven into the ground, while person 2 again measures 100 meters to the north, marking 200 meters. 8. This process is repeated to mark 300 meters. The north-south boundary line has now been established. To determine the east-west boundary line of the plot of land, the surveyors return to the initial ranging pole and complete the process again. This time, the measurement is 700 meters to the east. Surveying a rectangular plot. Once complete, the plot's boundaries are established and surveyors will have a better understanding of the land topography. The area of the plot can be easily determined. The plot boundaries were determined using a measuring tape, ranging poles, and a prismatic compass. Then, the measurements were used to determine the area of the plot. Surveying a non-rectangular plot. In this case, the plot's boundaries have already been established, but the shape of the plot is not rectangular. Here, the surveyors will measure the length of the sides and determine the plot's area. Before taking measurements, the surveyors need to determine which measurements need to be taken to determine the area. To do this, we apply our understanding of geometry. In general, to determine the area of a non-rectangular shape, determine the areas of common shapes that comprise it. Here, those are a square and a triangle. Later, we will calculate this area more directly, recognizing it as a trapezoid. But we will first develop the general case for any non-rectangular shape. Next, one can find the area of the common shapes and add them together to determine the area of the irregular shape. Here is what we know about determining the area of a square and a triangle. The area of a square equals the length of side squared. Area of triangle equals the length times the height divided by 2. Which measurements need to be taken by the surveyors? We know that the sides of a square are equal in length. Measuring this side will give the length of all 4 sides of the square. It will also give the height of the triangle. Which measurement needs to be taken to determine the area of the triangle? Measuring this side will give the surveyors the length of one side of the square plus the length of the triangle. If the length of the square is subtracted, the length of the triangle will remain. To determine the measurement of this side, the surveyors can use a measurement tool like a measuring tape or a Gunter's chain. In this scenario, the surveyors will use a Gunter's chain. Here are the materials needed: Gunter's chain, chaining pins, and 2 people. The measurements will be taken in a similar way to scenario 1, except here a Gunter's chain and chaining pins will be used. 1. Person 1 uses a chaining pin to pin the end of the Gunter's chain to the exact point at the corner of the square. 2. Person 2 walks until the gunner's chain reaches the other corner of the square. 3. More than one Gunter's chain can be used if the length of the side is more than 20 meters in length. The length of this side is more than one Gunter's chain. It is 3 Gunter's chain, 60 meters, plus 40 extra links, or 8 meters. Each additional link adds 0.2 meters, so 40 additional links adds about 8 meters. Therefore, the side shown is 68 meters long. Given what we know about squares, all sides of this square are 68 meters long. Next, this side of the plot will be measured. The length of this side is 5 Gunter's chain, or 100 meters, plus 30 extra links, or 6 meters. Each additional link adds 0.2 meters, so 30 additional links adds 6 meters. Therefore, the side shown is 106 meters long. Now that we know the length of the square is 68 meters, and we know that the length of the square and the triangle is 106 meters, we can find the length of the triangle. 106 meters minus 68 meters equals x, and x equals 38 meters. The surveyors now have all the measurements needed to determine the area of this plot of land. Remember, area of square equals length of side squared. Area of triangle equals length times height divided by 2. The area of the square equals 4,624 square meters, and the area of the triangle equals 1,292 square meters. So if you add the two, you get the area of the plot, which is 5,916 square meters. In this case, the boundaries lines of the plot of land were given, but the measurement of those lines was unknown. The goal was to determine the area of the plot of land. To do this, the surveyors used knowledge from geometry to determine the measurements of the necessary lines with a Gunter's chain. Then these measurements were used to determine the area. Surveying a trapezoidal plot. In this specific case, the non-rectangular shape being surveyed is a trapezoid. The area of a trapezoid is given by its height times the average of its two bases, the sum of the bases divided by 2. Surveyors would make the same measurements, but the calculation is simplified to be base 1 plus base 2 times its height divided by 2. And here we have an area of plot equaling 5,916 square meters.